Hi everybody, welcome to physics teacher classes. Okay, so today we are going to discuss numericals or problems based on laws of motion. So far we discussed Newton's first law, second law, third law, momentum, impulse, right? So on this, let us discuss problems one by one. First we start with the easy problems and we increase the difficulty level, right Nana? Yeah, see if the first problem. So problem number 1. This is our question. A force of 1 Newton acts on a body. So force is given. How much? 1 Newton acts on a body of mass 1 kg. So here mass is given 1 kg. It will produce in a body acceleration of 100 centimeter per second square, velocity of 1 meter per second square, acceleration. A, B, C, D options are given. Which option is? First let us calculate acceleration. See, both are in SI, Newton and kilogram. So both are in SI system. So we no need to convert this. Now what is formula? Acceleration equal to F net by M. So here what is the net force acting? Only one force is acting. So acceleration is equal to 1 by 1, that is 1 meter per second square. It can be written as 100 centimeter per second square. Yes, so option A is correct. So D is wrong because 980 is given. So here 100. What about velocity? Does it produce velocity? Yes, it produces velocity. To calculate velocity we need time. So velocity after what time? So time is not given. So we no need to calculate velocity here. Understood? If time after 2 seconds, what is the velocity means we can calculate. How? V is equal to U plus AT. So as it is starting from rest 0 plus acceleration is 1 into T is 2. So that we will be getting 2 meter per second. This is velocity after 2 seconds. But time is not mentioned in this. That's why we no need to calculate. Understood? Right. Let us see second question. So this is the second question. A 5 kg weight. So here mass is 5 kg is given. Here he is saying weight, we have taken mass. Okay. Why? See here the unit. This is the unit of mass. So you don't worry about that. Okay. By taking consideration into the unit, you must take the physical quantity. Right. Is accelerated from rest. So initial velocity 0 to 60 meter per second. So final velocity 60 meter per second in how much time? 1 second. Okay. Then what is the force acting on it? This is the given data. Okay. Now right. To calculate force, what do you require? M into A. So it can be written as M into, can I write A as V minus U by T? Because I have V, U and T. That's why I have changed my formula. Then that is equal to M. How much, Nana? 5. All are in the same system. Kilogram, meter per second, second. So all are in the same system. Right. So V is 60 minus U 0 by T is how much? 1. So 560 is how much? 300 Newton is the force, because all are in same system, means SI. So the force also will be in SI units. Understood? So what is the force in this case? Very good. Okay. So 300 Newton is the force. Clear? Right. Next let us see third question. Okay, see this question. So here what is given? You tell me what is given. A body of mass 40 grams. So M is equal to 40 grams. In each and every question, first you try to understand which is given. Okay, na? Right. So if you want to try the answer, you pause the video and try by your own. Okay, Nana? Right. So 40 grams is given. Moving with a constant velocity. Remember this. It is a constant velocity. So V is equal to how much? 2 centimeter per second. Right, Nana? On a horizontal frictionless table, the force on the table is, there is no friction because it is frictionless table. It is given that. Okay. Now what is the force on the table? Force on the table will be 0. Can you guess why? Exactly. It is moving with uniform speed. So it is given that constant velocity. When a body is moving with constant velocity, what is its acceleration? Acceleration is 0. Then how much is the force acting on the body? 0. Okay, so as the force acting on the body is 0, the force acting on the table also will be 0, as there is no friction. Clear, Nana? Very good. Yeah, see, this is another question. So a body of mass 2 kg is given. So given data I am writing, mass is equal to 2 kg, is sliding with a constant velocity of 4 meter per second. Okay, it is sliding. Okay, means moving with what? It is constant velocity of 4 meter per second on a frictionless table. Here also friction is how much? 0. The force required to keep the body moving with the same velocity is how much? Okay, so see this situation. This is the table, this is the body sliding on this. So as it is moving with a constant speed, okay, if the table has friction, okay, friction will be acting in this. So to maintain the constant velocity, we need to apply force in the forward direction when the surface is a friction. But here it is given that frictionless table. Then what happens? It continues its motion. According to Newton's first law, every body continues in its state of rest or of uniform motion. So as it is constant velocity, it moves till infinite distance. Okay, so how much force is required to maintain that? 0, because there is no external force acting on that to overcome that. If there is a friction, then to overcome the friction we need to apply force, but here frictionless surface, so it continues to move. Clear, Nana? Very good. Next problem. Yeah, see this question. A body of mass 2 kg. So first I am writing given data. So 2 kg of mass moving on a horizontal surface with an initial velocity 2 meters per second. Sorry, 4 meter per second. Initial velocity. You observe carefully. It is given that horizontal surface. In this case, he didn't say about the surface. Okay, that means is it frictionless or friction? So if it is not given, we should consider friction is there. Okay, now so comes to rest after 2 seconds, means its final velocity 0 after 2 seconds. Okay, Nana? Right? So now from this we can understand the surface applies a frictional force on the body. Okay, due to the frictional force, the body comes to rest after traveling 2 seconds. Then what is the frictional force here? How much is the force? Let us, that is MA. That is 2 into V minus U by T. Yes or no? Yeah, that is 2 into V is 0 minus 4 by 2. That is how much, Nana? 4 minus 4 newtons. So why we got minus? Right, it is opposite to the direction of the motion of the body. Okay, and now next what? If one wants to keep the body moving on the same surface with a velocity of 4 meter per second, the force required is how much? You tell me how much force I need to apply to maintain that speed. I need to apply on the body which is equal to the friction. Yes, then the net force is 0, so that it moves with the same speed. So how much force I need to apply, Nana? 4 Newton I need to apply on the surface, sorry, on the body, so that it keeps moving with the constant speed. Understood? Right, so this is the thing. Next, let us see one more question. See this question, Nana. A block of mass 2 kg. So mass, while reading the problem you should write data, so it consumes our it doesn't consume our time, it saves our time. Right, placed on a long frictionless horizontal table, there is no friction. Okay, table is pulled by a constant force F. Suppose this is the surface, on this there is a body, so there is a constant force acting on the body. Right, this is the situation. We try to imagine the situation. Right, Nana? Now it is found to move 10 meters. So distance is 10 meters in first 2 seconds. How much time is 2 seconds? Then we need to calculate F. Okay, come on. So it is at rest. How I said? Because the block is placed on a long horizontal friction. It is placed, so it is 0 initial velocity. Now come on, what is F? F is nothing but A, ma. So I can write m into. So A, I want to write, or I want to calculate A first. Okay, so that let it be. Now how can I calculate A? I have S U T. Okay, now I have what data I have, Nana? S U T. So I can use S is equal to ut plus half A t square. Yes or no? First I want to calculate A. So for that I will be using this equation because I have this data. Now that is 10 is equal to, as u is 0, this is 0, half into A into t square is 4. So that 10 is equal to 2A. From that A is equal to 5 meters per second square. Right, Nana? Now F is equal to how much? Simple, ma. M is how much, Nana? 2 into A, 5. That is equal to 10 Newton is the magnitude of the force. Clear? So as the given data all are in the same system, we did not convert anything. Directly we can substitute. Very good. Yes, see this question. A car is moving at 40 km per hour. So its initial velocity is given as 40 km per hour. Is to be stopped. Stopped means immediately you can write final velocity is 0. By applying the brakes in the next 4 meters. 4 meters. What is this? Distance. Because meter is unit of length. Okay, now if the car weighs, means weight of the car, that is 200 kg. Okay, now kg is given, so it is mass. What is the average force we must apply? Force is equal to how much? Okay, now see that here initial velocity is given in kilometer per hour and distance is given in meter, and these are in the same system but it is not. So first you convert that. U is equal to 40 into 5 by 18 meters per second. Yes or no? So this is our conversion factor. So this can be 100 by 9 meters per second. Come on now. F is equal to, what is the formula? ma. That is equal to A. I have U V S. So what is the formula? V square minus U square is equal to 2AS to calculate A. In previous case we have used S is equal to UT plus half AT square because I have data S UT. Okay, based on the data we choose the formula. Here I have V U S, so I choose this formula to calculate A. Then it is m into, I can write this as V square minus U square by 2S, A value. Okay, that is equal to m, how much, Nana? 200 into V square 0 minus U square, that is 100 by 9 whole square. Okay, by 2S. 2 into S is 4. Right, let us simplify this. So that is equal to, so you can write that as 200 minus, okay na, 200 into 100 square means I can write as 10 power 4 by 9 into 2 4 ja 8. Okay na. So that is, now if you simplify this, what are you going to get is 200 by 9 square na, 9 9 ja 81. So 81 into 8 into 10 power 4. If you simplify that, approximately you will be getting 3.1 into 10 power 4 Newton. This is the force applied on the body. Clear? Right. Next, another problem. See this question. In a TV picture tube, electrons are ejected from the cathode with a negligible speed. So let us take initial velocity is 0 and reach a velocity 5 into 10 power 6 meters per second. See, I am concentrating what is given. Okay na. So TV picture, this doesn't matter. What is given data we need to find out first. Okay, right. So and traveling 1 centimeter. So distance is equal to 1 centimeter. So we need to convert this into meter. That is 10 power minus 2 meter. Okay na? Yeah. Next, assuming straight line motion, find the force exerted. We need to calculate force, and mass of the electron is given. How much? 9.1 into 10 power minus 31 kg. Right, so what is formula again? Force is equal to ma. Okay, so to calculate a, what data do we have? U, V, S. Okay na, so we can use v square minus u square is equal to 2s, right? So m into v square minus u square by 2s is a, right nana? So that is m. So 9.1 into 10 power minus 31 into v square, so 5 into 10 power 6 whole square minus u square is 0 by 2 into s. So 2 into s is 10 power minus 2. Okay, so now we need to simplify this. So if you simplify, you will be getting 1.1 into 10 power minus 15 Newton. Clear nana? So you concentrate what is given in the problem, on given data only always. Right, let us see another model of problem. Yeah, see this beautiful question. A particle of mass 50 grams is given nana. First I am writing mass as 50 grams. As it is easiest, I can write 50 into 10 power minus 3 kg. Okay, next, on a straight line, the variation of a speed with the time is shown in the graph. Now what we need to calculate? Find the force acting on the particle at t equal to 2 second, 4 second, 6 second. Okay, now first let us calculate force at t is equal to 2 second. So to calculate force, what data we require? Mass and acceleration. Okay, so at a 2 second, it is as it is velocity time graph. At 2 second, what is the acceleration? So this is the graph. Okay na, the slope of vt graph gives acceleration. Okay, so as it is constant acceleration, okay, the graph shows that it is moving with constant acceleration. Acceleration from 0 to 3 seconds will be same, means 1 second, 2 second, 3 second, the acceleration is same. So that I will be calculating acceleration for this. So that is, acceleration is nothing but slope of the graph. So that is y2 minus y1 by x2 minus x1. So y2 is 15 minus y1 is 0 by x2 I have taken up to this, that is 3 minus 0. That is how much? 5 meter per second square. This is the acceleration at any point from 0 to 3 seconds. Understood na? Now force is equal to what? ma. So m is how much? 50 into 10 power minus 3 into a is 5. That is 250 into 10 power minus 3 Newton, or you can write that as 0.25 Newton. Okay na? Right, clear? Yeah. Next what? Next we need to calculate force at t is equal to 4 seconds. T is equal to 4 seconds. Now see here, at 4 seconds you observe carefully, the body maintains constant speed from 3 to 5 seconds. Means at 4 seconds also the velocity is constant, therefore acceleration is 0. Then what is the force acting on that? Is 0. Clear? Next, force at 6 seconds. Next thing is force at 6 seconds. You observe carefully, at 6 seconds means 5 to 8 seconds the body's velocity is decreasing. It is in retardation. Okay, so it is moving with constant retardation. Okay, then I can calculate from 5 to 8 seconds its acceleration. So acceleration is equal to y2 minus y1. y2 is 0 minus y1 is 15 by x2 minus x1. x2 is 8 minus x1 is, I have calculated up to this, 5. That is minus 15 by 3. That is minus 5 meters per second square. Therefore force is equal to how much nana? ma. That is again what you are going to get, 50, okay, into 10 power minus 3 into minus 5. That is again 0.25 newtons. That is minus. Okay sir. So in this way, from the graph also you can calculate the things. Clear? Yeah. Next, see another model. Now see this question. Raindrops of radii 1 mm. So radius of raindrop is 1 mm. Okay, if you convert this, this is minus 3 meters, 10 power minus 3. And mass 4 mg. What is meant by mg? 4 mg means 4 milligrams. That is 4 into 10 power minus 3 grams. That is equal to 4 into 10 power minus 3 into 10 power minus 3 grams. Okay, na? So simply I can write 4 into 10 power minus 6 kilograms. Sorry, kg. Okay, so that is. Next, are falling with a speed of 30 meters per second. So initial speed is given 30 meters per second on the head of a bald head person. Okay, the drop splash on the head and comes to rest. So final velocity is 0. So by seeing the question, you should not get fear. It's a big question. So what we need is very little from that. Okay, now. So you think you should not feel that the question is very big. Okay, so we require only piece of data from that. Right, Nana? See what I am underlining, that is the required data for us. Now assuming equivalent to that, the drop covers a distance equal to their radius. Means how much distance they are going to cover equal to their radius. That is nothing but 10 power minus 3 meter on the head. Estimate the force exerted, okay, na, by each drop on the head. Okay, so when we feel the force applied by the water drops around, when you are standing in the rain, when raindrops fall on that, it exerts force. How much force is that he is asking? Very simple. Okay, see, the question is very big, but the data is too simple. Right, Nana? And now to calculate force, what is the formula? F is equal to ma. Okay, we have mass and acceleration we need to calculate. So what data I have to calculate acceleration? U, V, S. So that again, what is that? V square minus U square by 2S. Very simple. Got it? Yeah, now write down what is the mass. Mass is given as 4 into 10 power minus 6. V square is 0. Minus U square is 30 square is 900 by 2 into S. So 2 into 10 power minus 3. So if you simplify this, we are going to get the answer. Now see that 2 2 is 4. So 2 into 10 power minus 6 into 900. This minus I am keeping here, divided by 10 power minus 3. Okay, now, and now simplify this. Minus 2 into, okay, 2 into 9 I can write as 18. 18 into 2 zeros, if it comes up, plus 3, 5. So 10 power minus 1 Newton. This can be written as minus 1.8 Newton. Right? So this is the force applied by each drop on the head of the person. Yeah, see this question, Anna. It's a different kind of question, different model. Gravel is dropped into a conveyor belt at a rate of 0.5 kilogram per second. So what is this? Kilogram per second means kilogram is mass. Yes or no? By second means time. M by T is given. How much? 0.5. Understood, Anna? Clear? So from the units I am writing the data. See here. Means in 1 second, half kg is falling on the conveyor belt, which is falling gravel. Means like small stones, or you can take as a coal or sand, whatever it may be. Okay, 0.5 kg, half kg is falling every second on the belt, which is moving. Okay, so the extra force required in Newton to keep the belt moving with 2 meter per second. What is the velocity? With this velocity, it should move with that constant velocity. Now it is a best example for variable mass system. Here velocity is constant, mass is keep on changing. So then how much force is required to keep that belt to move constantly? So that is what, Nana, what is the formula I gave? Very good. V into m by t, dm by dt means m by t. Very simple. So that is 2 into how much? 0.5. How much, Nana? 1 Newton. How much force is required? 1 Newton force is required to keep that belt moving with a constant speed. Clear? Very simple one. Now let us see one more question. Right, see this one. A rocket is ejecting 1 kg of gas per second. Again, what is given? M by T is given. How much? 1 kg per second. Okay. Right. Now, a velocity of 60 kilometers per second. With what velocity is it ejecting? 60 kilometers per second. That is 60 into 10 power 3 meters per second I can write. Okay. Then the accelerating force on the rocket is how much? Again, this is an example of variable mass system. Then what is the force, Nana? V into dm by dt or m by t. That is equal to V how much? 60 into 10 power minus 3 into m by t is 1. So what is the answer? 60 into 10 power minus 3 Newton is required. Okay. That is the same. Very easy. Right? Yes. Yes, see this question. A block of metal weighing 2 kg. So here mass of the block is given as 2 kg is resting. So what is its initial velocity? 0 on a frictionless surface. There is no friction. Right. It is struck by a jet releasing water at a rate of 1 kilogram per second. Means m by t of water is 1 kg per second. Means in 1 second 1 kg of water is coming from the jet. Jet means this is. So there is a pipe. From this pipe water will be coming out. Okay. This is falling on the block. Okay. So now what happens? And the speed of the jet. Okay. Means speed of the water is given. How much, Nana? That is that is u water. Okay. 5 meters per second. The initial acceleration of the block. For the block we need to calculate acceleration. Okay. So simple, very simple. Now you have to calculate first how much force is exerted by the water on the block. Understood? Okay, sir. So force exerted by the water on the block. If you calculate that, you will be getting force. You have mass of the block, then acceleration can be calculated. Right. See that force exerted by the block is how much? Mass of the water per second into speed of the water. That is m by t into u water. That is how much, Nana? 5 into 1. That is 5 Newton is the force. Now what is the acceleration of the block? Acceleration of the block will be is equal to force applied by the water divided by mass of the block. Yes or no? Right. That is 5 by 2. That is 2.5 meters per second square is the acceleration of the block. Clear? See how easy the problems are. Okay, the thing is you need to understand what is given in the problem, what we need to calculate. That is the thing is required. Next, see another model. See this one. A ball weighing 10 grams. So what is that? Mass is 10 grams, or you can write that as 10 into 10 power minus 3 kg, or simply 10 power minus 2 kg. Right. Hits a surface vertically with a speed of 5 meters per second. Right. So let us take this as a surface. This is the ball hitting this surface vertically. Okay. With what speed it is hitting the surface? U as 5 meters per second. Before hitting the surface, it has U. Right. And rebounds with the same speed. Again, it is moving up with the same speed. V is equal to minus 5 meters per second. This is very important because initial velocity is downward, final velocity is upward. So that is minus 5. You be careful while working with this. Now the ball remains in contact with the surface for 0.01 second. 0.01 second it is in contact with the surface while hitting. The average force exerted by the surface on the ball. Okay, right. Here the force exerted by the ball on the surface or surface on the ball are same according to Newton's third law. Now let us calculate force. So F is equal to how much? That is only our question. Now see here what is given? Mass of the ball is given. Okay, V, U and T. So from this I can write F is equal to M into A, that is equal to M into, I have calculated A. What data I have? V, U, t. So v minus u by t, that's it. Okay na, right? That is equal to m is how much, Nana? 10 power minus 2 into v minus 5 minus u 5 by t is 0.0. See, if you take this as plus 5, you will get 0. Yes or no? Yeah, be careful. Now let us simplify this. So that is 10 power minus 2. Okay, if I take this, you can write as 10 power 2 into minus 10. So how much is the force? Minus 10 Newton. This is the force applied by the surface on the ball. Clear, Nana? Right. Let us see another problem. Okay, right. These are the few questions, model questions. So this is not the end of this chapter, Nana. So more things are there to learn. Okay, so more concepts also are there. So now next video we are going to work on how to draw free body diagrams. These are going to very important. So to see that video, so you check whether you learned contact and non-contact forces video or not. Okay, that is more important in drawing free body diagrams and making equations of motion. That is very important, right, Nana? Yeah, thank you very much. You subscribe and share my channel. Thank you.